If you're someone who's trying to run databases at the same speed as Nimbus or Firebolt, or maybe even a bullet train without impacting the performance, then you're looking for something called the NoSQL database, which is a common database called Amazon DynamoDB, which is quite popular in this space. And in this video, we'll talk about the security best practices for Amazon DynamoDB. We'll do a walkthrough of the console for how you can create an Amazon DynamoDB through a business use case, as you would expect to do in a real life job. If you are someone who probably understands DynamoDB and what they are, and just want to get straight to the security best practice, then use the timeline at the bottom to get straight to the security best practice, where we talk about the Amazon side as well as the client side of doing security best practices for Amazon DynamoDB. However, if you are new to DynamoDB and want to understand what is it, why do people care, and do the Amazon console walkthrough of how do you create one, then stick around and let's move forward. For people who were in our last week's bootcamp class for Amazon RDS security best practices, which I'll leave a link for on the top right corner, this is a bit different. This is not a relational database. This is a non-relational database, and a common example is DynamoDB. Now, you may wonder, why do people care about a non-relational database? People who are trying to build internet scale applications like LinkedIn, Instagram, YouTube, where you have performance at stake, where millions of people are logging in every single day, every single second, and you want to have peak performance no matter what the scale of the audience is. Unfortunately, a lot of relational databases require a lot more maintenance and start to get a bit slow as it starts growing exponentially. NoSQL databases have been proven to maintain the same performance level irrespective of the workload. Now, some of the examples that are shared by Amazon themselves is the American Football Super Bowl, which is probably one of the biggest events in the world and has millions of users that log in from everywhere in the world. Even those folks are using DynamoDB in the background. There are other use cases as well. For example, it is being used by companies like Capital One, Vanguard, and a lot more other companies. Now, these slides are from the Amazon slides themselves. So these are all Amazon customers for gaming, Riot Games, Electronic Arts. If you are watching Netflix, Amazon Prime, all of that is on DynamoDB as well. There's a lot that you see in terms of globally scaling application that uses DynamoDB in the background, essentially as a NoSQL database to give you the same performance so you never miss out on a show. One thing to consider about DynamoDB, because Amazon DynamoDB is a managed service, it is a managed service provided by Amazon, so they take care of where it is located. So Amazon takes care of the infrastructure, the maintenance window, and anything to do with what it is standing on. What you as a customer may have to worry about, how would you access it, what would you put on it, and we'll do a walkthrough of the business use case, what we can talk about. But for the context, we probably should also understand, how would you access a DynamoDB table? Now, as I mentioned, Amazon DynamoDB is within the Amazon account. If you see in the diagram on the left, you can probably realize the Amazon account, this is the older diagram as it used to be, has EC2 instances inside a virtual private network, and Amazon DynamoDB is outside, and basically this is how you would respect it. Now, what happens is the endpoint that is provided by Amazon DynamoDB is universal for that account. It is universal as in the URL is the same across each account, but what would differ is the table that you're trying to access. So because it's on the account and your account is because it's on the account and your EC2 instance or your virtual machine is within a network, it has to go out to the internet and come back and then access Amazon DynamoDB and come back all the way. Now, this is, as you can imagine, it's probably a bad idea, because why do you have to go all the way to the internet and come back in again? There definitely needs to be a better way. Now, some people obviously use NAT gateways, and these are on the right, the more newer logos. So apologies, I couldn't find diagrams around this, but I just wanted to make sure I show you the other picture as well. You can also use NAT gateways that allow you to have the similar kind of access as well. Now, that's the first kind, but what you can also do, which is probably the better recommended way, is to use something called a VPC endpoint or a gateway endpoint. Or some people even have used private links as well. The idea behind this is that instead of going out, now in our previous scenario, we were going out from the internet gateway into the internet, coming back in DynamoDB. But now, because we can extend private connections within Amazon, our virtual machine, which is the EC2 instance over here, only needs to be routed to the VPC endpoint. That could be talking directly to the DynamoDB table. Now, obviously, you can have VPC endpoints for other services like S3 and other places as well. And if you'd like us to do a video on that, definitely give us a comment and we'll definitely create one for you. This on the right is the gateway endpoints as depicted with the newer logos. Essentially the same thing. There are two private networks, and both of them are trying to connect to an instance of an S3 bucket and also DynamoDB as well. Now, this is a second method of logging in to access DynamoDB tables. Now, sometimes you may also require additional boost of traffic, and for that you can use something called the DynamoDB Accelerator. These are clusters that are usually found within the virtual private network so that there is no latency. But these DAX clusters can talk to Amazon DynamoDB, which is still in the account context, and hence the reason for it to be outside the virtual network. But that's another way for you to access it. This increases speed quite a bit. So if you're looking at microsecond, millisecond kind of a difference, then this is the option for you. Another way to connect with DynamoDB table is using cross-account roles. You may have two accounts, as you can see in the diagram over here. One of them has a DynamoDB table, but the application is running using Lambda in another account. You can use that as a cross-account IAM role to be able to access a DynamoDB in another AWS account, which is another great way. Now, these are few of the many ways you can access it. We'll talk about some more in the security best practice, but I wanted you to be aware of this before we walked into the whole conversation about what is a business use case. So the first business use case, if you are a cloud engineer or a cloud architect, you have been tasked by your manager or boss that, hey, you need to create a Amazon DynamoDB table for developers to use for their web application in AWS, which should allow them to have uninterrupted flow for a large amount of traffic in microseconds. But in some scenarios, they might have to work with millisecond response time scenarios. So you have to add a DynamoDB accelerator as well to improve the response time of the DynamoDB table linked to a web application in AWS. Now, if you are someone who's probably new to the world of IT and probably to the cloud world as well, the scenario over here is that you are provided with a task to create a database called DynamoDB, which obviously would give you high performance. And that's the reason why microsecond and millisecond response times, but you also want to make sure that you're able to do it effectively. So let's do a quick walkthrough on the console and let's create a DynamoDB table for you. So I'm on the AWS console now, and I'm going to search for the search bar DynamoDB table, comes up over here. Again, as I mentioned, it's a managed service. And sweet. This is the default screen. One thing to note over here, security best practice number one, make sure you are in the right region where you're supposed to be. Do not create a DynamoDB table in the region you're not supposed to be, because the data that you produce and work with should always be in the region that you're allowed to put the data in. So starting by that, let's go and easy create a table. You can create a table by clicking on the orange button, or you can click on tables over here and click on the orange button over here. But I like this one over here, which I have lost for some reason. So I'm just gonna, but I enjoy just going to the dashboard. So I'm just gonna use the orange table over here. I'm gonna create a table. I'm gonna call it, because I am a Harry Potter fan. Because I'm a Harry Potter fan, I have Hogwarts as my table name. Now, a DynamoDB table is supposed to be a key value pair, and keys are usually a partition key or a sort key. Imagine this as the unique identifier that you would use to define attributes and things that you're going to use. So the partition key in our scenario is going to be the different schools, because there are 4 major schools in Hogwarts, and I just want that to be the key. In this scenario, I'm going to keep it simple and not use the sort key. I am going to use the default settings, but I have the option to go and customize the entire thing if I want to. But I think it would be more valuable if I talk about it from a perspective of the default settings first. That way, it's easier for you to understand the security best practices. Now, a few things to note over here: read capacity, write capacity, RCUs and WCUs. This is basically how you're charged. RCU and WCU are the way that you would be charged for your DynamoDB. Basically, it's how many writes and reads you're doing and the capacity you're using. There is a feature called deletion protection, which is off by default in this scenario. However, if this was real life and this was production environment where all our important data is, I would make sure that this is turned on. But there are other ways around this as well. But for the moment, let's just focus on that. The other thing we would also notice is that the encryption key management system, which is the encryption at rest, that is owned by DynamoDB tables. Now, in my scenario, my organization is okay to use the KMS and let Amazon manage the key. But in your scenario, you might have to use the customized setting and go, well, I need to have AWS managed key, or I might have to store it in a separate account. But for this bootcamp, so people can create one. And that's pretty much what you have to do. Now, it is important to have tags so they can identify which particular stream does this belong to. In my case, I'm just assigning it to engineering, because tagging is important from a hygiene perspective. And next thing you know is just create a table. All right, so the table is being created. Should take a couple of seconds. All right, so the table has been created, and let's go into it. So this is pretty much what any table in DynamoDB would look like. As I mentioned, it is a key value pair. I have defined key, but I don't have any values. So my table should pretty much be empty. To see what your table looks like, you can click on Explore Table Items, and it usually instantly runs a command, and I have 0 because I don't have any schools defined. Let's create a couple of rows. So I would like my first school to be Ravenclaw. Again, Hogwarts fan. Now, as you can see, it has already shown Ravenclaw over here pretty much when it came up. I didn't have to run the run command for scan. Let's add a few more. So I'm just going to add my other houses. I've got Slytherin. I'm going to create one more, Gryffindor. So I've got 3 schools created, and I can run this, and I can run the scan command. I would get this. Now, at this point in time, I'm comfortable to say that I have created a database table which a developer can access. Now, to access this, they would have to use the endpoint, and I can leave the URL for this over here, but essentially it's the generic endpoint provided by Amazon. So it would look something like this, where the first is the service name as per the service code over here. We're trying to access DynamoDB. The second is the region code. For us, it was US West 2, or at least in my scenario, it was US East 1 because I'm the Virginia region. So my US 1, yep, US East 1, but you could be in another region. So your region may be different. Make sure you create this in the region that you want to operate in. And remaining is AmazonAWS.com, followed by a slash and the table name that you have created. In our case, the table name is Hogwarts. That's pretty much how you would access it. So it's fairly simple for you to be able to access it. So your application should be able to access it directly. But if you remember, our business use case also has a second part, which is to create a DAX cluster. So we go into DAX. At the moment, I don't have any clusters. I'm going to create a cluster. I'm going to give it the same name because I just don't want it to be confused. So I'm just going to go, okay, Hogwarts underscore DAX. We'll just call it that. Now, I don't want to give any options. I'm just going to go for the default family. I do want to call out most of these options would cost money. So definitely want to keep an eye out for that bill so you don't run these for too many hours. As you can see, the higher the machine you would probably go for, the higher the cost may be. I'm just going to go for the cheapest option that I can find. Oh, I need at least 2. Okay, fine. All right, I've got 2. Nope, I need at least 3 apparently. Oh, it does say that as well. So it does say that we strongly recommend at least 3 nodes, of course. This is a production instance, so we have to do what's recommended. And yep, I've got my name defined, cluster defined. Oh, sorry. I'm just gonna go with that. That should be. All right. So now we are on the subnet. As I had shown in the diagram before, we are in the territory of a VPC now because a DAX works and operates within a VPC. So I'm just going to call it over here Hogwarts. I'm just going to call it Hogwarts subnet. I've got the VPC already defined. I'm just going to use a subnet, this whichever one. So sweet. Now I've got a group that I've created for my subnet, and that's my subnet for my virtual network. I'm going to use the default VPC, and I've got automatically assign availability zone. This is probably the important part where I'm just going to have IAM role being defined for my DAX. The reason this is important is because it is this IAM role that makes it access different services like DynamoDB as well as any IAM role or any other application that has to access. In my scenario, I only want the AX to be able to access only my Hogwarts table, nothing else. So I've selected that. I made sure I have encryption at rest, encryption in transit, and as you can see, there is no additional cost, no additional cost. So I'm going to make sure I have turned these on, and I have a parameter group that I can work with. I don't really care changing that right now. I'm going to put my tag because it's part of engineering, and it's good hygiene to put that so people can recognize what it is. And yeah, that's pretty much it. All right. All right. I would not click on create cluster because I know this would cost money. So I'm just going to cancel this. But if you want to finish off the experiment, you can definitely kick it off there. But for the purpose of working with this, you have the DynamoDB table created, and as well as you have the region correct. And you just basically can start working with the DynamoDB table. At this point in time, we are finished with the business use case. So let's talk about the security best practices as we kind of walk through them as well. There are 2 sides to the security best practice for any managed service in the Amazon context. There is the Amazon side where the shared responsibility would prevail. Then there is the client application side. From an Amazon side perspective, there is a bit of a gray area that I should probably start off the whole conversation with. Because Amazon DynamoDB is part of an account and not really part of a virtual network, to be able to access that service, you have to go out to the internet from a virtual machine, which is in a private network, which is usually where your applications are. It has to go out to the internet and come back. This is why before I walked through the console, I spoke about the different type of access that DynamoDB cables can have. The most recommended option is to use the VPC endpoint or private link option that allows you to have a private connection within the same AWS account, because that generic endpoint URL that you would use for DynamoDB and with the table name as the only differentiator, it becomes really crucial for you to be making sure you're not going out to the internet and making your DynamoDB table basically available on the internet for the rest of the world to access at that point in time with a generic name. Hopefully, because it is all only provided for people with the right credential, it's not really exposed to the internet, but at least for you to be able to limit access to the right database for the right people, you want to be able to use VPC endpoints. The next part is the data security and governance part. The first one being the compliance. When I was trying to create the DynamoDB table in the console walkthrough, I called out specifically which region I was going to create the DynamoDB table in. This is important because the data that you work with as a company, whether it's customer data or employee data, you have to make sure that you are working in the region that you should be working in and not outside it. For context, if you are an Australian citizen, you probably want your data to be remaining only in Australia region. But in my scenario, my customers are in the US region, which is why I have it in US Virginia. But for example, if I was in California with the CCPA, or I was in Europe where there's GDPR, and there's a GDPR version in London as well, so UK would have its own version, you may have to be a bit more careful for where you create your database. And as a security person, or at least a security minded person, you should definitely make sure that you are asking the right question when you're trying to create the DynamoDB table before you put that in. There are obviously legal reasons for you to include that in there, but the other side of compliance is Amazon has done their part of making sure DynamoDB tables by themselves, or DynamoDB, the service itself, is compliant to a lot of security industry standards. But you may be working for an industry that may have its own standard that you should also consider, and making sure that it does comply with those services is important before you start using them. There's also another way to make sure you only work in the regions you're supposed to. You can use something called the Amazon Organization SCP, or Service Control Policy, to manage things like who can delete the DynamoDB table or DynamoDB creation, or you can lock your region. For people who were also part of the first video that we did for this particular bootcamp, you would remember the website cloudsecuritybootcamp.com. And over here, we have all the links for the bootcamp. And one link to consider is the GitHub one for specifically this class, where if you click on it, you should be able to go straight to my GitHub profile and you would see AWS security best practice policies. Over here, you feel free to star it or watch it and fork it and to make it your own. Making it star would also mean that every time I make a change, you get to hear about it. You can fork it and make it your own. What I've done recently is I've added another policy in here, which is the delete deny DynamoDB table. If you can't see it, hopefully that should help you. It's in the AWS SCP best practice policies, and it's also running in JSON. By the way, shout out to the person who helped me make all these JSON files added into my repository. I only had YAML, so shout out to the person who made it happen. Thank you so much. I just want to quickly shout out. That's the person, Nelson Osaji. Hopefully, I didn't mispronounce your last name. Thank you so much for your help with this as well. All right. So, SCPs is another way for you to make sure that you don't allow accidental deletion of data. Another thing you can also do with these days in DynamoDB table, as you are creating it, you can also have delete protection on the table itself. Conveniently, there are services within AWS you can use to monitor and react to malicious behavior on a DynamoDB table. For example, if you notice that the audit log capability, which is provided by AWS CloudTrail, suddenly starts noticing there are a lot of requests for create DynamoDB or maybe to delete a DynamoDB table, but they're all failing. Now, that's a malicious activity, one would imagine. So it's worthwhile looking at these logs being created and creating some kind of alarm from it. Now, as of March 2023, Guard Duty still does not support DynamoDB. At least it's not supporting as per documentation and as per the console, where it doesn't really talk about what databases are covered. So if you are looking to use some creative ways to secure your DynamoDB table so you can react automatically, you probably should consider the AWS config rule that would be enabled and needed to be required in the region where the DynamoDB table is running, because config rules are a region-based service as well, so it's hilarious. But as you can imagine, a lot of this does add to the bill as well. It's important to know how these would work. Like the organization SCP would not cost you money, but config rules would, and CloudTrail does not cost you money. The S3 bucket used for CloudTrail would. The VPC endpoint as well. DynamoDB itself costs money, but At least it's covered from an encryption perspective, which is good. Talking about encryption, probably should talk about the application side as well. The recommendation from Amazon is that even though they do provide capability for encryption at rest, they do recommend using client-side encryption if you are using DynamoDB to store sensitive information. So it, in a way, do not use DynamoDB to store sensitive information. Probably still use the relation database for storing a lot of sensitive information if you want to for long-term storage. But DynamoDBs are more for fast reaction. And as you can imagine, if you're working with an internet scale application, I don't know, like Instagram or Facebook, what are you really doing? You're just having username and password saved once, but every time you log in onto your phone, it just automatically logs you into your Facebook, Instagram, and then you're able to just simply start browsing. And what you're doing is just literally liking a picture or commenting on a picture, or maybe doing a live stream or sharing this, or maybe doing live streams like what we do on Cloud Security Podcast every weekend on our LinkedIn and YouTube pages. You probably can use that as a way to store information in DynamoDB, but it's not really sensitive. So, DynamoDB can help. Talking also about DynamoDB storing information, you can use things like IAM users as well as a IAM role, as well as a Cognito identity pool. But in most scenarios, I would say don't use an individual IAM user or group. Instead, try and go for an IAM role or a Cognito identity pool. The reason for this is IAM users and groups probably would have permanent credentials which are never rolled. However, using things like IAM role as well as a Cognito identity pool, which again, we did a video on this, and I'm going to leave a link for that as well. That was part of the bootcamp where we spoke about different kinds of authentication. What does AWS Cognito do? And the idea behind this is that if you use things like IAM role, identity pool, you are creating temporary credentials which would automatically stop working after a certain point in time instead of being stuck around with permanent credentials, which hopefully you're not storing in the application. You're literally just using it in the AWS console as well, or maybe in the AWS CLI. Now, for some reason, if you are creating users that are using to manage DynamoDB, make sure there are a limited number of users and you lifecycle them appropriately based on the permission they should have. So have some kind of a role-based access to make sure that the individual or the groups or the IAM role that has access to DynamoDB only has enough access. For example, they should only have access to tables that they should be able to access. They should not be able to delete the DynamoDB table, should not be able to create new DynamoDB table. There might be different scenarios you might have to consider based on the risk appetite of your organization and the threat modeling you would have done for the application as well. We also spoke about Dynamic Accelerator, which is the DAX. That service, because it is inside a VPC, it uses something called a service IAM role. Now, I would recommend using the read-only access to DynamoDB table in that IAM role, and you may choose to have a direct write access, say, to the Dynamo, a straight write access to a direct write access to a DynamoDB table, but that would depend on the architecture you have defined and how you want it to be configured. Irrespective, make sure you're not trying to access DynamoDB from the internet. Instead, try and use a VPC endpoint, as I called out in the previous slide. And in case you have on-premise, you can also use things like site-to-site VPN or Direct Connect, which is a fiber optic service provided by AWS for connecting directly into AWS from your data center. So if you have the capability to do a site-to-site VPN or a Direct Connect, definitely use that as well. That's pretty much what I wanted to cover from a security best practice. And at this point in time, I would say you can confidently walk up to any AWS console and create a NoSQL database. In this case, the Amazon DynamoDB with a single or multiple table data model. Hope you got value from this. And if you enjoyed content like this and you would like us to create more content around any of these topics, definitely leave us a comment for the topic you would like us to cover next. And if you enjoy content like this, I would definitely recommend checking out the remaining videos in Cloud Security Podcast. We talk about cloud security all day, every day on this channel. So if you like and maybe spread the message, or maybe even subscribe as well, so others find out and you get notified when the bell icon hits that there is a new video out, because we are running this bootcamp on a weekly basis. So you would see me or you would hear from me on next week's class as well. Enjoy the rest of the bootcamp, and I will talk to you in the next class. Peace.